Today we're going to look at the layout of the solar system. The layout can best be explained if you go back and look at how the solar system formed. So we go back to the solar nebula. You have a sun forming. You have dust and gas forming around it and clumping up together. You have areas of the solar system that are hot because they're right next to this forming sun. You have areas of the solar system that are going to be cooler because they're farther out from where this sun's going to form. We have to look at condensation temperatures now. Here's a table of condensation temperatures. Condensation temperature, or condensation, means to turn from a gas to a liquid to a solid. So if I look at this table, I can see that heavy elements tend to condense out of gas at higher temperatures, and lighter elements tend to condense out of the gas state at lower temperatures. So if we replace the sun on this table and show what might happen in a solar nebula, you have the sun creating high temperatures in the inner solar system. That means the heavy elements will be able to condense out, but not the lighter elements. If you go farther out in the solar system, the outer planets are going to be places where lighter elements can condense out. There's an imaginary line that separates these locations. They call it the frost line, meaning that within this point, no water can form, can condense into a liquid or a solid. And outside of this point, water is allowed to condense out of its gas form and form into planets and moons. So if we go back to our layout of the solar system, we see that the inner solar system, Mercury, Venus, Earth, and Mars, is places where heavy elements have condensed out, but very little water. Too hot when they were forming for water to condense out of that solar nebula. If we look to the outer planets, Jupiter, Saturn, Uranus, Neptune, this is a place where light elements would have been able to condense out of the solar nebula. And lots of water. This is why we see all of the moons of the outer solar system are almost entirely composed of water and ices. Well, this leaves us with a big question. Where did all this water on Earth come from? Well, it turns out that the amount of water on Earth isn't as much as it looks. It covers a large surface area, but if you were to wrap all that water on the surface up into a sphere, it wouldn't be much volume. You can see in this picture, they've done just that. They've taken all the surface water off and they've clumped it up into a sphere. The result is not that much water. But we still have to wonder where this water came from if the Earth formed inside the frost line where no water should have been able to condense out of the solar nebula. Well, for that answer, you'll have to stay tuned.